All right, let's get through this applications of trigonometry review packet. Intro to vectors. A vector is a directed line segment with length and direction. Now, length is actually called magnitude. We can use the two words interchangeably, if you will. The component form of a vector is where the V1 is the horizontal component and V2 is the vertical component. All right, now let's try to figure out how we figure out what the horizontal and the vertical components are. So we basically say, how do I get from -1 to -3? Well, I have to subtract 2. How do I get from 2 to 5? Well, I would add 3. For CD, how do I get from -6 to -4? Well, I would add 2. And how do I get from 8 to 4? I would subtract 4. And the reason we're doing that is because the first coordinates are the x distance, or the horizontal distance, and the second coordinates are the y distance. So now I need to find the magnitude of each vector above, so I just have to do the square root, and I'm using this answer right here. And I'm doing -2 squared plus 3 squared, and that's going to give me 4 plus 9, which is equal to the square root of 13, and that's not reducible. For the magnitude of vector CD, I'm just going to do 2 squared plus -4 squared. That's going to give me 4 plus 16. That's a little too big. That's going to give me the square root of 20. And I can rewrite the square root of 20 as square root of 4 times the square root of 5. And square root of 4 is 2, and then we keep our root 5. All right. So now let's go ahead and add and subtract vectors. The first thing we're going to have to do is find what AB is. So I've got to write my 3 first, and then my AB, well, how do I get from 4 to 1? I subtract 3. How do I get from 2 to 5? Oh, I add 3. Minus, now let's do my CD. My CD is going to be how do I get from -2 to 4? Well, that would be to add 6, right? And then how do I get from 3 to -1? I would subtract 4. Now let's go ahead and distribute that in. That's going to give us a -9 and a 9. And then if I'm going to distribute this negative in, you can think of it as plus a minus and then transfer that negative in. So that would be plus -6 plus 4. Or a positive 4, if you will. Okay, and now to add our coordinates, we're just going to do -9 plus -6, which is a -15. And then 9 plus a 4, which is a 13. And that's our final answer for that one. Okay, next one is we have to find what BC is. Well, BC is going to be from 1 to -2, so that's a subtract 3. And then we've got a 5 to 3, well, that's a subtract 2. Plus 3, where'd that 3 come from? That should really be outside the vector, that's my bad. The DA, I'm going to go in this order, so I'm going to go from, how do I get from 4 to 4? Well, that's a 0. And how do I get from -1 to 2? That would be adding 3. So I'm going to multiply this through, and we're going to be given -3, -2, plus 3 times 0 is 0, 3 times 3 is 9. Now I'm going to add my x coordinates, and that's going to give me -3. Then add my y coordinates, 9 minus 2 is a 7. There I go, right there. Okay, next one here, I'm asked to find v plus w, and so all I have to do is do 3i plus 2j, and I have to add that, because it's just v plus w, to 3i, and then minus 5j. And so a 3i plus a 3i gives me a 6i, and a 2j minus a 5j gives me a minus 3j. Now in the review packet I stopped right there, but we do want to keep going. This would be 6 times 1, 0, minus 3 times 0, 1. So this would give us 6, 0, and then we can think of this as a plus minus and go like that. So that would give us plus a 0, minus 3, and that's going to give us a 6, negative 3. All right, next one here, we have to find the magnitude of 2v minus w. So first thing I do is I actually do 2v. Well, 2v is going to be double everything of this here. So that's going to be a 4i minus a 6j. And since it's just minus w, I don't have to worry about that too much. So my 2v is going to be this. So that's going to be 4i minus 6j. But then I'm subtracting my w. Remember my parentheses. So this is going to be 5i plus 8j. Distribute that negative, and I'm left with 4i minus 6j minus 5i minus 8j. A 4i minus a 5i, that gives me a negative I. And then a minus 6j and a minus 8j gives me a negative 14j. So this is going to give me negative, and then I've got 1, 0 for that guy, and a minus 14, and this is going to be a 0, 1. So I'm going to change this to a plus negative, and I'm going to distribute that through. I'm also going to change this to a plus negative, distribute the negative through, so that gives me a negative 1, 0. And then this gives me a plus 0, negative 14. So this gives me a negative 1, negative 14, because I combine negative 1 and 0 to get negative 1, and then I combine 0 and negative 14 to get there. All right. Add the following vectors. So here we've got 150 newtons at 180 degrees. And here we've got 120 newtons at 60 degrees. So my f sub 1 of x is going to be 150 cosine 180. And that gives me negative 150, which makes total sense because you're going to the left 150. And then f sub 1 of y is going to be 150 sine 180, and make sure you're in degrees when you do this, and I get 0. All right, now let's find my second force. The x value for that's going to be 120 cosine 60, which I get a nice 60. And my s sub 2 of y, that's going to be 120 sine 60, and that's going to give me 103.92. So my f sub x, I'm going to add all the x values, add this to this, and I get a negative 90. And my f sub y, I'm going to get 0 plus a 103.92 is obviously a 103.92. All right, let's go ahead and let's find our magnitude by doing negative 90 squared plus 103.92 squared. Just get that straight in your calculator, and I get 137.47 newtons. So that's our magnitude, or our length. Now we have to think about where this angle is. Well, here we're given that we've got a negative x and a positive y. So that would give us a negative x in this direction and a positive y be this. So I'm going to do a theta equals tan inverse. And I'm going to keep it positive. I'm a super positive person. And I'm going to do y over x, or 103.92. divided by my x of 90. And again, I'm keeping it positive, and when I do that, I get theta is equal to 49.11 degrees, which means that this is 49.11 in here. So I have to do 180 minus 49.11, and I get 130.89 degrees. So we've got both our magnitude and our direction. Just make sure you're looking at the right quadrant. All right, let's add these vectors. So we've got 60 newtons at 140 degrees, and here we've got 130 newtons at 30 degrees. Actually, I got tricked there. It's not 30 degrees. What is it? That's negative 30 degrees if you think about it. So it's actually 330 degrees, right? All right. So let's have right here, we've got f sub 1 of x equals, and then we've got f sub 1 of y equals, and then I've got f sub 2 of x equals, and then I've got f sub 2 of y. So what is this going to be? Well, this is going to be 60 cosine of 140. This one's going to be 60 sine of 140. Then this one's going to be 130 cosine of 330. This one will be 130 sine of 330. All right, I'm just going to pause the video real quick and add those values to save time. All right, so those are the values that I got. You can go ahead and check your answers with me. But I'm now going to add the x values right here to get my f sub x. And then I'm going to add the y values right here to get my f sub y. And when I do that, I get a 66.2 or 62 in the f of x direction, and then a negative 26.43 in the y direction for that force. So we're going to find our magnitude by doing this. Don't forget your parentheses, especially with the negatives. And I get about 71.67 newtons. Okay, so there we go for our magnitude. Now we have to go ahead and we have to think about where our angle's at. And so we can think of that as our f sub x is 66.62 in the right direction, but then we're down 26. So we're actually in the fourth quadrant because I'm looking at this right here for going down. So to find theta, we're going to have tan inverse of y over x, trying to keep it positive. So my y was going to be 26.43 from right here, keeping it positive, over 66.62. And I get 21.639, or 64 if you want. However, that's located right here. That's where my theta is. So I actually have to do 360 minus that answer right here, and that's going to give me what I want for this whole angle right there. And so when I do that, I do 360 minus 21.639, I get roughly 338.361 degrees. All right, let's go ahead and do a vector problem here. So vector A has a length of 15 and an angle of 205. We've got B has a length of 4, and then we've got 100 degrees, and then vector C is 50 degrees, and it looks like a length of 6. So the first thing we're going to do here is, I'm just going to go with this, save some time and get this down. Give me a second. Okay, so you can see here that I've really just taken the information, and that this would be 15 cosine 205 and then 15 sine 205, and then I went to each vector and did the same thing. So our next trick is really to add up all our x values, and I get a negative 9.04. So I was just adding up this value, and this. And then adding up the y values, I am adding this one, and this one, and I get a positive 2.2. So going ahead and doing my magnitude, I'll do my magnitude over here. I get the square root of negative 9.04 squared plus 2.2 squared. That gives me 9.3, so that's newtons, and that's my magnitude. But I do have to think about where my f sub x and f sub y are, right? So this is where we're adding up all the components and figuring out that the total force, or the f sub r, is going to end up being over here. And the reason I know that is because I'm going negative 9.04 and then I'm going up 2.2. So I know I'm located there. So I'm going to do theta equals tan inverse. And again, I like to keep it positive. So it's going to be 2.2 over 9.04. And that gives me theta equals 13.68 degrees, which is really just right in here. So to get the angle that I really truly want, which is this one, I do 180 minus that, and I get 166.32 degrees, and that's my direction. Okay, this problem is the same exact thing in terms of the setup, so I'm just going to go ahead and quickly write down what all the force 1, force 2, etc. is going to be. Okay, so you just have to use the calculator to get these answers, and then once we've done that, we find that our f sub x is going to be 4.64. That's just adding up all the x values, these numbers right here. Then I add up all the y values, and I get my f sub y, which is going to be equal to 6.34. This is nice. This is in the first quadrant, so it's going to be relatively easy. So let's go ahead and find the magnitude. I just do the square root of 4.64 squared plus 6.34 squared, and that gives me 7.86 newtons. And then because I know this is in the first quadrant, I'm going right 4 up 6. I just have to do theta equals tan inverse of y over x, which is 6.34 over, just do the division sign here, divided by 4.64. And then I get theta is equal to 53.8 degrees, and I don't have to do anything with that in terms of subtracting from another thing. All right, that's it for the first part of this packet, and now we're going to go ahead and move into polar coordinates in the next video.